All right, everyone, welcome to the video. This video, we are specifically focusing on the atom and its structure. So we're going to define what the atom is, we're going to talk about the structure of an atom, and then we're going to differentiate between different types of atoms or different atoms of different elements. So first we need to define what an atom is, and an atom is just the smallest particle of matter. It's the smallest we can break something down and to consider it matter. Anything that's in the universe, aside from energy, contains atoms. Now, some atoms, we may have a larger cluster of atoms, or we may have a different type of atom, but everything that is made up of matter contains atoms. And we can see that not all atoms are the same. We've got, specifically on the periodic table, we've got hundreds of different atoms, and those are elements. Elements are made up of atoms, and as you can see, each element is different in how it's made up, or how things are aligned inside of it. So you can kind of think of this like animals in biology. We know that humans have 23 pairs of chromosomes, or 46 total chromosomes. And if you look at this diagram to my right, or your right, you can see that each different animal has a different number of chromosomes, just like each element has a different number of protons, which we'll talk about in a little bit. Each animal has a different number of chromosomes. That's how we identify different elements. Now, with the atom, we can talk about its structure. And firstly, we can compare it to a cell in biology, where the center of the cell is called the nucleus. We've got the same concept in an atom. We've got the nucleus of an atom. That's the center of the atom. And the nucleus contains the neutrons and the protons. So within this small little area, within the center of the atom, we've got the protons and we've got the neutrons. Then on the outside, in shells located around the nucleus, we've got electrons. So protons and neutrons are in the center of the atom, and electrons are kind of moving around on the outside. So in this particular diagram, we have two electrons. We've got this one, and these are kind of floating around in empty space outside of the atom. And that's something that's important for students to remember, is that the atom is actually made up mostly of empty space. We do usually envision an atom as being very tiny dots, but a lot of what makes up that atom's volume is empty space, and then just a small tiny bit of it makes up the center or the nucleus of that atom. We call the protons, the neutrons, and the electrons, we call these subatomic particles because they are smaller than an atom. So they're subatomic particles, and they carry a different charge. Generally, we're looking for an atom to have a neutral charge, meaning that the number of positives equal the number of negatives. And each different subatomic particle has a different charge. So firstly, we've got protons, and protons have a positive charge. If you can remember protons P with the P in positive, you should have no problem remembering this. Protons are always positively charged, so they always carry a +1 charge. Electrons, on the other hand, always carry a negative charge, or -1 charge. So one electron is a -1 charge, one proton is a +1 charge. So you can see that if you have the same number of protons and electrons, we're not going to have any positive charge or negative charge. We're going to have a neutral charge. Now, the third subatomic particle is the neutron. Neutrons are neutral, pretty easy to remember because basically it's the same word. We just drop the ONS and we add the AL. So neutrons are neutral. So each of these subatomic particles have their own specific charge. Now, this is a periodic table. It's nice and colorful, looks pretty. But what a lot of students don't know is that this periodic table contains a lot of information that we can use in chemistry that's going to be useful for us, and we're going to need to know how to decipher that periodic table. We will break down the groups of the periodic table, why it's different colors and things like that, but I do want to focus more on specifically what each box means. When you break down the periodic table and look at one element, what does that information mean to me, or what does that tell me? So we're taking a zoom in at carbon. We're going to take a look and see what information we can get from carbon's periodic table square. So I'm just going to go from the top down. We see carbon. That's written on the top. That's just the element name. That's easy enough to remember. That's how we know what the element is, the element name. Not all periodic tables give you the element name, but this one, most of them, what we'll use in class, should have the names on them. All right, directly below the carbon, the word carbon, we've got this number 6. This is called the atomic number. Number 6 is the atomic number. If you look at the periodic table, you can see that each of the elements, we've got 1, 2, 3, 4, 5, 6, all the way down to 118. And the periodic table is arranged by the atomic number. We're going to talk more about the atomic number later on in this presentation. Just know that number 6 is the atomic number. Then we come down to the C. This is the element symbol. So this is carbon symbol, which is C. And you'll notice that each element has its own unique symbol, and that's how we identify that specific element. And then lastly, this bottom value, this is the atomic mass. So this is telling me how much one atom of carbon weighs. And in this case, carbon has a mass of 12.011 units. We're just going to call them units for now. So if you look at the periodic table and you look at the specific squares where the elements live, you should be able to see that each element has its own unique features. And we're going to use this information for a lot of stuff in class. So this is important for us to understand right off the bat. So subatomic particles, we already talked about those. We talked about the charges, but why are they important? And if you look at different types of information, if you look at different graphics, you should be able to determine the number of subatomic particles that each element has. And I'm going to walk you through how to do that with this first example. So with this first example, we know that we have the atomic number, which is this number 6, but where does that number come from? Well, the atomic number comes from the number of protons. So this bottom number right here, this bottom number is our atomic number. That tells me, running out of writing room here. That tells me that if I have 29 protons, I'm dealing with copper every single time. Copper is always number 29. So if I wanted to keep just a little diagram right here to keep track of how many subatomic particles I have, I'm just going to be able to do that. So if I know my atomic number is equal to the number of protons, that must mean that I have a total of 29 protons in this particular copper atom. Moving it right down, mass number. The mass number is equal to the number of protons and neutrons. This top number right here, this is your mass number. So your top number, the bigger number, is your mass number. The bottom number is your atomic number, which is the number of protons. So my mass number, I'm going to write this here, mass number equals 63. All right, so far, I didn't really need to know really any prior information except for what each of these numbers represents. Now, if I wanted to figure out, let's just say I wanted to figure out the number of neutrons here. And if I knew that the mass number is equal to the number of protons plus the number of neutrons, if I set this up like a math equation, 63, which is my mass number, equals the number of protons, which is 29, minus neutrons, I'm just going to write n here. Hopefully, using a calculator, you should be able to easily solve this for n. How would we solve for n? If I want to get rid of 29, I'm going to subtract 29 from this side. I'm going to subtract 29 from this side. That cancels these 29s out. (63 minus 29 is 34, so my number of neutrons comes out to 34. So using the mass number, I was able to determine how many neutrons I have because I already had my number of protons right here. I have my mass number. Now I just need to figure out how many neutrons I have. All right, last thing we need to do is we need to determine how many electrons we have.